Hi and welcome back. My name is Scott Xiong, and today I'll be showing you some muscle deformation in Maya. I am using expression code to power my muscle deformations. I'll have more on that later. I'll show you how it works first. Here I have my regular test scene. I have a twist joint for my arm, and I have a left up arm which I'll be using for deformation. All it uses is expression code and the weighting on these joints and moving these joints according to what I have in expression code. So I have a small animation already in the scene file, and as you can see, it's just nothing's happening. It's what you expect. Now if I apply my expression code and then I reanimate, you can start to see the muscles bulge. Now this is very cool stuff. And here is the wireframe for it. I'm going to zoom in and I'm going to play the animation. Okay, so that's all it is. Now what we're seeing here is the scale Y value of the left up arm being manipulated with expression code. And it obviously looks like it's because of the rotation values of our forearm. But in truth, it has actually nothing to do with the rotation value of the forearm at all, which I'm going to explain in a sec. Okay, so let's say we have here our arm, and these are the joints that represent our arm. There's going to be a little bit of math in here if you haven't noticed. I never thought I'd be using math outside of high school, but well, you never know. So in any case, we also have a joint here, which represents our bicep. You'll have to pardon the terrible drawing here. However, this is pretty much the easiest way for me to explain it. So here you have your arm, and you have your joint that you want to modify. And of course, it's scaling out. Now, if we were to label these points as A, B, C, then we almost have something similar to a triangle. Yes, I said triangle. Try not to hurt your head too much here, because we're going to go into some math. So you can already see where I'm probably going with this. Instead of using the rotation value of our forearm, what I'm actually using is the distance value between points B and C. And as they change, they manipulate the scale of our desired joint and cause it to bulge and settle. Now it sounds easy, but trust me, when I came to this conclusion, it took a little bit of effort to get to. Now it doesn't end here. Parts like your bicep, it peaks out at a certain range of motion when their arm's coming up. So that means you need to define a minimum and maximum value where you want the bulge to primarily happen. And of course, adding that into your calculations and your procedure is another task all in its own. The next important step for us to take is to find the distance between points B and point C. And in order to do so, we need to know the position values for point B and point C. There are many ways of doing this. The method that I used was using the xform command and querying the world space translation of each node and then finding the difference. The value returned was the distance between point B and C. Now that we have the distance between points B and point C, we can take that value and divide it against the sum of the remaining sides. Doing so gives us a value which we use as a parameter in another procedure, which basically is a Hermite curve, which drives our deformation. So thanks for joining me, and I hope you enjoyed the video. I'll be going through the procedures necessary to perform the deformations in another video. So until next time, take it easy. Bye.